this is one of my favorite topics. It's such an important part of modeling and taking a look at data, and it's finding important variables. So it could be that you're working with data sets that are quite large, and not every one of those variables is going to be important. And it's also possible that those variables are correlated with each other, and you don't want to model all of those, or you're going to get some strange results in your model. So what we're going to talk about today is finding those important variables and finding something that we'll call unique variables as well. So those that are going to help drive that model. And before we get started in the software, I just want to go through a few slides and just talk through, why we want to do this and why you should consider, some extra steps in finding these important and unique variables before you start modeling. And a lot of the times when you have data, you just want to get into the software, start creating some models, and that's fine. But there's a lot of pre-processing or pre-work that you could do to help make those models either more relevant or give yourself less of a headache down the road if you do some adjustments to your modeling workflow, and particularly if you're going to start working with genomic data. So in these types of data sets, you've got thousands of columns, or maybe you've got historical process data that has lots of process variables that might be correlated, or you've got other types of data that looks at huge amounts of demographics, and you want to try to do some modeling or inference there. Or you're working with spectral analysis. So if you're looking at chemical spectra or some other type of spectral result, a lot of those data points are correlated. If one signal's going up, the ones next to it are probably moving in similar directions. And so if you're trying to work with these sorts of data, there's another step that you should consider. And I think previously we had talked about going right to important variables, but I think what I like to think about now is going to some sort of dimension reduction step where you've got all of these columns and you want to reduce the number there. And there's two real ways that you can do that. You could consider doing variable selection, and that's what we're going to talk about today. So variable selection is finding important variables and those unique variables, but you can also consider another method, using latent variables, like doing principal component analysis or clustering or partial least squares. These are all other ways to reduce that data set to make it easier to handle and maybe more impactful in your model. And if you want to learn more about this, my colleague Bill Worley gave a great mastering jump a few weeks ago on working with highly correlated data sets that you should definitely check out. But we're going to stay away from that today. We're going to talk about these variable selection methods. So finding important variables and unique variables. And I wouldn't say these are technical terms, but what I mean when we talk about an important variable is a variable that explains variance in a response. So if you move a variable in a direction up or down, that the Y response changes proportionally in some way. And when I talk about unique variables, these are those that are uncorrelated with other independent variables. So if you have correlated variables, that can lead to some challenges in modeling a system. And so we're going to use ways to find both those important and those unique variables. And the goal here is just to take that big raw data set where you've got many columns, or you've got correlated columns, or you've got this raw data set, and then we're going to find those important variables, those that predict some sort of variance in our Y response, and then narrow that down further to those unique variables to get that reduced data set. And that reduced data set then can be used for many different things. Maybe you just need to explain some observations in historical data, or you want to build a predictive model, explore some potential interactions. So if you've got lots of columns, then the number of interactions or higher order terms are going to be tremendous. So reducing that data set first to look for those is sometimes beneficial. Or maybe you just want to find some factors for a DOE. So you want to reduce that data set down to weed out any variables that might not be important in predicting your response. And so what we're going to talk about today is this production problem. And this is simulated data from some hypothetical factory that's producing product, and maybe we average typically around 85% yield, and there was a big drop in that yield. A lot of batches went out of spec, and we want to do some sort of root cause analysis to understand what parameters might be affecting that response. And we're going to use a number of different platforms today. You know, good old trusty Graph Builder, no matter what your use case is in JMP, you can probably use Graph Builder to help get you started. And multivariate analysis platform. So these help us find trends and maybe check for correlated variables. We're also going to use predictor screening and response screening. So these are going to identify those variables that can affect the response. These are going to find those important variables. And today there's a few ways to handle those correlated variables. I'm going to talk about cluster variables today. It's kind of a fun platform that takes all of these important variables or variables that you want to look at, whether or not they're important, clusters them together, and then gives you the most representative variable in that group. So we'll show how to use that platform. And then depending on how time goes, we'll jump into fit model and either do some additional response screening, maybe on some of those higher order terms or interactions, or look at stepwise regression to start building a model. And let's see, so that's all I wanted to do. Hopefully that gives you an idea of what we're going to cover today. And so let's go right into the data set. So really, before you even start the analysis, before we even start finding these important variables, there are a few other steps that you might consider taking before you start modeling. We're not going to talk about these today, but you really want to clean up your data. The last thing you want to do is start working with a data set that has miscoded variables or variables that might not be representative of your system. So you want to clean up and prepare that data. You want to figure out how you're going to handle outliers or missing data. So are you going to impute those missing values? Or are you going to ignore them? And then you really want to make sure that that data set is the best representation of the system that you can get. And because last thing you want to do is spend a lot of time modeling to realize that maybe the data set wasn't prepared enough, and then you have to go back and do it again. Or even worse, you make decisions based on models on data that wasn't cleaned up appropriately. And so there's a lot of different tools in JMP to help you do that. We're not going to talk about these today, but you can find these in the same menu item that we're going to be working in. So under the Analyze menu, you can go down to Predictive, or down to the Screening menu, and then you can do some data cleanup. You can explore outliers, find missing values, and impute new values. You can explore patterns in your data. Maybe you've got certain values that are more frequent than others, so you can look at those. And so these are great tools for taking a look at a particularly large data sets. We're going to use the response screening and predictor screening platforms primarily today. But before we do that, I have been working as a side project on some fairly large data sets, and column management can be quite cumbersome. It's like, how do you manage when you've got hundreds or thousands of columns? How do you work with those columns in a way that helps you navigate the platforms efficiently? So I want to show a couple tips and tricks that I've found that are helpful for me, and hopefully you'll find them helpful for you as well. And the first one I want to show is just this column viewer. So in this data set, you can see I've done something already. I've grouped all of my process variables together. And so I can show you how to do that. So I'm going to right click and ungroup those. And so to group columns, you just highlight all the columns that you want to group together. And then I'm just holding down Shift, I click, and then you can right click and group those columns together. And what this does is it gives you a single handle. So when I click on that group, it's actually selecting all the columns in that group. So if I want to move these into a platform, all I have to do is that single click on the group, and it'll transfer all those in. So what I want to do, though, is do one quick check. And in addition to finding outliers or missing values, sometimes it's good to find columns that don't have any variance. So you don't need to waste time trying to use columns that are constant. Maybe it's a setting that never changed, or there's so little variance that the standard deviation is very low, you can ignore them. So what we're going to do is find those in column viewer. So I'm going to go to calls and then column viewer. And what we're going to do is just take a look at all the columns. So I'm just going to select them all. and I want to say show summary. So down here, now I've got summary statistics for all my columns. When I've got categories, I get the number of categories and the number of missing values. So like in those where the assembly line or the equipment ID. And then when I've got numeric data, I get my min, max, mean, and standard deviation. So whenever you have a data table like this in a report, you can right click on it and go to sort by column. And we're going to sort by standard deviation ascending. And so when I do that, so all of my categorical data doesn't have a standard deviation, but all of my numeric data, these are columns that have constant values. So you know, they're not going to do anything for a model. So I just want to get these out of my out of the variables that I want to look at, and this will help because in some platforms, if you have constant columns, it's going to not work in the platform, and you'll just get a warning saying that they're going to be ignored. But we can just pull them out. So I'm just going to click on these, and you can see over here, as I select columns, you can see that the number of columns are changing that I've got selected. So I'm just selecting all of these, and I want to open this group. And so I can find where they are, and I can just right click, and I'm going to say ungroup columns. And that just puts them down at the end, but they're all still selected. So then I can just right click again and say group. And so now I want to change this to something like constant. And that way I've got another handle, and I don't have to worry about those. So when I move in and out of a platform, I don't pull those along with me. So now I've got my variables of interest isolated from those constants. And so I don't want to delete them, but I just don't want to find them every time I navigate a platform. So so let's see. So let's move on to just doing some quick exploratory data analysis. So Graph Builder is really my first place to go, or even before that, column headers. So if you're in jump 15 or later, I believe, you'll have the little icon up here that turns on the column headers. And this is a quick and easy way just to get an idea about what's going on in your data. So you can just select some of the continuous variables and see how that trickles through. So if I really want to see what might be affecting my low yield, you know, I can see right away without doing any modeling that this parameter 2 might be important and things like that. But when I've got, you know, let's see, nearly 600 columns, even column headers, you know, it's going to be a little cumbersome to work through. But we can get some quick information with those column headers. The same with Graph Builder. So we can go into Graph Builder and we can take our yield and we can put in a parameter like this parameter 1. And in this case, I'm going to turn on a column switcher. And so I can, you know, select my parameter 1 and replace it with a few others. But once again, you know, I've got hundreds of columns. But if you don't have too many columns, this is a great way to just cycle through, take a look at your the relationships in your data, and quickly start to understand some of the relationships between your Y variable, in this case our yield, and the different parameters. But in this case, once again, you know, we've got too many columns. We need to do some variable reduction here. So I'm going to close this down, and the first place we're going to go is response screening. So response screening is essentially going to plot or graph a linear relationship between all of our X variables and the Y variable. So to get to response screening, we're going to go to Analyze, Screening, and Response Screening. And so in this platform, I've got my yield, which I'm going to place in as my Y. I can put categorical information in here, so it'll do, you know, means comparison or on those against my Y, and I can put all of my continuous variables. So I'm going to ignore those constants, and I'm just going to grab my continuous variables. There's a few options that you can run down here, but we're just going to go with the defaults today. And I want to click OK. And so what I get here is, and if you're running on version 16 or lower, when you run this, you'll get a couple different data tables. So one really nice improvement to 17 is all those results are consolidated into a nice single window that's tabbed. So we get our false discovery rate p-value plot up here. We're not going to go into a lot of the statistical details here, but essentially very low p-values are going to be more significant, more important at predicting that response than those with high p-values. But down here, we can also take a look at some other summary statistics. And if we were interested in the R-squared value, really nice thing about this is since it's not a data table like in prior versions, it's in this report table, I can just click on it and sort my table by that R-squared value. And right away, I see there might be some problem here. So something shouldn't have an R-squared of 1, and I can see, well, I guess there's a data point in there that only has 2 values, so it's all it takes to make a line, and it's perfect. So we might not want to consider that value, but we might want to learn more about these other values. And so these all have R-squared values at about 0.45, and they go down to negligibly low. We can navigate this platform, and let's say I have, this is still screening. I'm okay casting a really wide net and at finding some important values. So let's say I've just got an R-squared cutoff of 0.1. So I can navigate this platform by the red triangle up here, and I can say, let's select everywhere in this table where that R-squared value is greater than 0.1. And I click OK. And I'm going to hold Control down on my keyboard and click off this 367 parameter, since it's we think that there's a problem with that column. And so now I've got all of these variables selected in my response screening window, but you'll see they're not selected in my data table yet. So to kind of transfer this information, I can go up to the red triangle, and I'm going to say select columns. And so now you can see I've got 54 columns selected in my data table. And once again, I'm going to unselect that yield. What I want to do is just open this up, and now I want to pull these out. So I want to isolate some of these important variables. So I'm going to say ungroup. I'm going to collapse that, and then I'm going to regroup. And we can call these, important 1. So these passed our response screen as some sort of important variable, and we could have made a lower or higher R-squared cutoff, but 50 variables is a lot or a reasonable amount for this stage. So we've gone from that 500 and nearly 600 variables down to 50 with response screening. And this is really just testing those linear relationships in our data. But if we went back to that graph builder plot that we had, let's see, where I've got some of these variables. Oops, let's put yield there, and I come back here. We can see, maybe a linear relationship isn't really the best way to explain some of these the relationships between our yield and these parameters. Maybe there's a more complicated relationship, something nonlinear. So we can screen those really well with Predictor Screen. And Predictor Screen is a decision tree based method. So we can go into Analyze and just mentioning here, so I'm using Jump Pro 17.1, but everything that I'm showing is available in Standard Jump. And if you're in Standard Jump, you can create your own decision tree by going to Analyze, Predictive Model, and you have the partition model there. And that's another way to understand and find some important variables. But instead of just building one decision tree, we're going to go to Screening and go to Predictor Screening. And so what this does is it's going to create, 100 or 100 decision trees, or as many as I specify here. But the difference between the partition model and Predictor Screen is it's going to create a decision tree based on, a random selection of rows and a random selection of columns. create that decision tree. Then it's going to do that again and again and again up to the number of decision trees that we specified, and then average them all together. And so this way, you kind of can take a look at smaller effects. So if you've got some variables that are dominating a decision tree, this kind of it works through and finds other relationships that might be there. So in this case, what we're going to do is I'm going to load in all of my variables again. So I'm going to take all of those parameters, put them as my X. So these are the ones that were not important in response screening. I'm also going to put the ones that were important in response screening just to see if they are also important in predictor screening. And we'll put that categorical in there. And then I need to put a Y value in. And so now that we've got all those variables loaded in, I click OK. This takes just a second or so. So it's going to create all these decision trees, average them together. And then what we get in the output is like a rank order. So from most important down to least important in terms of predicting variance in that yield. And so the top parameter, this is not necessarily the portion of the variance that it was predicting. It's essentially the portion of models that used this variable to create a split in that decision tree. And so this parameter 26 showed up the most as an important variable for creating a branch in that decision tree. And then, so on and so forth down to, variables that showed up very infrequently. But once again, we're going to cast a wide net. And so maybe I'll grab the top 50 variables here. The nice thing about Predictor Screen is that it actually selects the variables in your data table. So the columns are being selected when I select them in here directly, and we can see that something kind of cool. So 17 of those were shown up as being important in that response screening, but this is found another 33 that didn't show up in response screening as important. So I think this just shows it's nice to do both methods, and you might there's no real downside to doing them both ways and then figuring out from here where to go. So let's pull these out now. So I'm going to find something, and I'm going to ungroup and then group those again. And I pulled them out of the response screening, but that's okay. So it pulled the ones that were selected as important one. It also pulled those into the second group. So we'll call this important two. So now from that initial 600 or so, nearly 600 variables, we've reduced it down to 88 or so variables. So we've done some dimension reduction already, but I don't think we wouldn't want to jump into a model quite yet, because maybe we know from this data set that we expect these to be correlated. Maybe these are sensors that are sensing temperature at different points in a process, and so if one of those sensors is at a high level, then the ones near it are also going to be at a high level. So we're going to want to shift gears now and start looking at some unique variables. So finding which of these variables are correlated and how to handle those. So what I want to do now is use multivariate analysis, and we're going to use this more as a visualization tool. We're not going to use that to do any analysis necessarily, but there's a nice way to visualize what correlations there might be. So to get to multivariate analysis, I'm going to go to Analyze, and I'm going to go to Multivariate Methods. And if you're interested in doing additional multivariate methods like principal components or partial least squares, this is where you would go to do that. We're going to go to multivariate, and I'm just going to load those important variables, because I don't really care if any of these unimportant variables are correlated at this stage. I've identified these as those that predict some variance in my response, and so I want to focus on them. So I want to cast those as Y columns, and I am going to get an error because multivariate only allows numeric variables. So I think I have one categorical in there, and we'll just say, okay, it's just going to ignore it. And you notice that these are all being cast as y, so I'm not putting in my y variable because I'm not trying to relate these variables to my yield. I'm just looking between all these variables what the correlation structure looks like. So with those all cast in there, I click OK. And I get a very overwhelming table of numbers. And so the first thing that happens when I see that is I ignore it, and I get a much nicer output here. So this is what I'm looking for, just some visual cue of what's going on in my data set. And I have a gradient pattern that I like to use for these. So I'm just going to change that. I made this one just to help draw out some of the differences and show white space where there's no correlation. So what we're looking at here is every variable is essentially plotted against every other variable. And so the diagonal is not important. So it's parameter 2 plotted against parameter 2. So we only have to look at, half of this triangle. Or half of this square, just the top or the bottom quadrants. And so what this is showing is anything that is highly positively correlated, and this is the lowercase r correlated. It's not an r squared value, so we get directionality. So if two things are positively correlated, they will show up as orange, and if they're negatively correlated, so as one goes up, the other goes down, they'll be blue. And so we do see these large regions of variables that are correlated. So these are nearly perfectly correlated, R of 0.9. We can see some patterns in here. So this is just telling us right away that we need to do something with this data. We can't just go and start modeling this, or we're going to get a model that is not very useful. These are not all independent, truly independent variables. So if we were doing some multivariate analysis, principal components, that's one way to reduce the correlation structure. But here we're just going to, instead of creating some sort of latent variable, we're going to find the variables that are most representative of some group of correlated variables. And so the way that we're going to do that is use a cluster variable. So what we're going to do is do some cluster analysis and group all of those variables that are similar, group them together. And then JMP is going to do another analysis and say, okay, out of all those variables that are clustered together, which one is the best representation of that group? So let's go and do that. So to do this, we go to Analyze, and we're going to go down to the clustering menu. And there's lots of different things we can do to cluster here. But we're going to go down to Cluster Variables. So in cluster variables, I'm going to load in my important variables. And once again, I'm not, I can only load in numeric variables. And I'm not putting in my yield because I'm not trying to relate these variables to yield. I already know that they are important in explaining variance and yield. So I just want to look at the correlation structure within these variables. Once we get those in there, I click OK. And what I get is, once again, a lot of outputs. I'm just going to step through, and we get this correlation structure. So it looks pretty similar to that multivariate analysis that we did. But what's happening is it's something a little bit different. So now all the different clusters have been grouped together. And what we get is a cluster summary. And this cluster summary is telling us that out of all of those variables, and so we've got 88 different columns, we can group those 88 columns into clusters. Looks like there's 15 different clusters here. Cluster 2 has 13 variables in it. And the most representative variable is this 538. And the way JMP determines that is it says, okay, well, in that cluster, it can explain about 70% of the variation within that cluster. And that cluster represents about almost 10% of the variance within all of the variables. And so there's some additional metrics here that JMP has figured out to say, okay, well, which one is the most representative? And if you look at the cluster members, so let's look at cluster 1. So cluster 1 has 11 members, and they're all here. And so you get some metrics here. So you want to have high R squared within the cluster, and then low R squared with the next nearest cluster. And so in this case, let's see, so cluster 1 is saying 24, or I guess it's the R squared within versus the next closest, and you get this ratio, and you want this ratio to be minimized. And that's how JMP is determining which is the most representative variable. So if I want a proxy for all of these variables in cluster 1, I can just use this parameter 24. And there might be a reason that that's important. Maybe these are all parameters that are closely related with each other in the system that we're studying. And so you have to use some of your system knowledge, domain knowledge to make that determination. But if we want to create a model, now we can just use these. Once again, I think I can select these, and we can see that they are now selected over here in my columns. So just by selecting these columns, I'm passing that information back to my data table, and I can use my little handy dandy trick to group these back up. And so now we've got, you know, our reduced 15. So we can call these, you know, model variables or whatever we might want to call them. So now I've got a handle on just those 15 most important cluster variables, or maybe that's what I'll call them, cluster variables. And now I've got, you know, a reasonable size data set to start doing some modeling or start looking into this data set even more, finding out why these are important. Yeah, so I think that's how we use cluster variables. There's other methods to use, but I think this workflow is a good one to get started with. So what do we do with this now? So now, you know, we can go in and we can start fitting a model. So I can go into analyze, and I can go into fit model, and I can grab my cluster variables and just look at those main effects. And now I can put my yield in there, and we can just go and run it. We have enough observations. So now, you know, we've done this analysis, and so it's not surprising that all of these are fairly important, because we've done a lot of work to make sure that we're grabbing the most important ones. You know, there's a lot of noise here, but you know, we've got an R squared value of 0.6, and we've got a p-value that's showing this is significant. So this is a good start to some sort of modeling system. And if we wanted to, now we can also go in and find those interactions. So I can go back to analyze, and I can go to fit model. And you know, if I was concerned that there were interactions between variables or higher order terms, you know, it'd be really challenging to take a look at all 600 of those. But I can, you know, take a look either at the most important cluster variables, or I could grab some more and go into model, and we'll take a look at, you know, two-way interactions, for instance, and go into yield. And there's another personality up here that we can choose. So we can actually launch response screening from this window. So just like we did response screening in the screening menu, we can do response screening here to look at interactions and in higher order terms. So when we run that, we get the same output that or similar output that we were seeing before. But now we're taking a look at those two-way interactions, and we can understand if there's some worth continuing to look at more deeply for our modeling, without having to go through you know, some stepwise regression first.